Good day, everyone. My name is Jericho from BIT2K, here to explain to you things you need to know about mass airflow sensor. But first, what is a mass sensor? The mass airflow sensor is one of the key components of an electronic fuel injection system in your car. It is installed between the air filter and the intake manifold of the engine. The mass airflow sensor measures the amount of air entering the engine or the airflow. Types of mass airflow sensors. Moving vane meter. The volume airflow sensor measures the airflow into the engine with a spring-loaded air vane attached to a variable resistor. The vane moves in proportion to the airflow. The voltage is applied to the potentiometer and a voltage appears on the output terminal of the potentiometer, proportional to the angle the vane rotates, or the movement of the vane may directly regulate the amount of fuel injected as in the K-Jetronic system. So if you have seen a fuel sensor, it also works like that, where it has a potentiometer and as the fuel slowly drops, the output signal sends it to the fuel gauge. But in a VAP sensor, it tells the mass of air flowing inside the air intake manifold to the ECU to measure the fuel to inject to the engine. Next. Membrane sensor. An emerging technology utilizes a very thin electronic membrane placed in the air stream. The membrane has a thin film temperature sensor printed on the upstream side and one on the downstream side. A heater is integrated in the center of the membrane which maintains a constant temperature similar to a hot wire approach. Without any airflow, the temperature profile across the membrane is uniform. When airflow across the membrane, the upstream side cools differently from the downstream side. The difference between the upstream and the downstream temperature indicates the mass airflow. The thermal membrane sensor is also capable of measuring flow in with both directions, which sometimes occur in pulsating situations. Technological progress allowed this kind of sensors to be manufactured on the microscopic scale as a microsensor using microelectromechanical system technology, such as microsensor reaches a significantly higher speed and sensitivity compared with macros, macroscopic approaches. Cold wire sensor. The GMLS engine series use a cold wire map system that works similarly to the hot wire map system. However, it uses an additional cold resistor to measure the ambient air and provide a reference for the hot resistor element used to measure the airflow. The mesh on the map is used to smooth out airflow to ensure the sensor have the best chance of a steady reading. It is not used for measuring the airflow per se. In situations where owners use oil gauze air filters, it is possible for excess oil to coat the map sensor and skew its readings. Hot wire sensor. A hot wire mass airflow sensor determines the mass of air flowing into the engine's air intake system. More on this sensor in future slides. Function of a map sensor. The air mass information is necessary for the engine control unit to balance and deliver the correct fuel mass to the engine. Air changes its density with temperature and pressure. In automotive applications, air density varies with the ambient temperature, altitude, and the use of force induction, which means that the mass flow sensor are more appropriate than volumetric flow sensors for determining the quantity of intake air in each cylinder. Okay, a little information. So if you remember, this is the main problem with carburetors in which where if you are in a high altitude, it feels like the engine is not getting enough air and when below, if leveled in sea level, that's it. When you're in sea level, it feels like the engine is running a little bit too much lean. So this is the solution for electronic fuel injections to measure the air flowing inside of the engine to mix the air intake mix a fuel air fuel mixture ratio. How hot wire map sensors work. A hot wire mass airflow sensor has a small electrically heated wire, hot wire as it's called. A temperature sensor installed close to the hot wire measures the temperature of the air near the hot wire. When the engine is idling, a small amount of air flows around the hot wire, so it takes a very low electric current to keep the wire hot. When you press the gas, the throttle opens, allowing more air to flow over the hot wire. The passing air cools the wire down. The more air flows over the wire, the more electrical current is needed to keep it hot. The electric current is proportional to the amount of airflow. A small electronic chip installed inside the airflow sensor translates the electric current into a digital signal and sends it to the engine computer. The ECU uses the airflow signals to calculate how much fuel to inject. The goal is to keep the air-fuel ratio at the optimal level. In addition, the ECU uses airflow readings to determine the shift positions of the automatic transmission. If the airflow sensor doesn't work properly, the automatic transmission might shift differently too. So this is the example of what I've told. This is from the air cleaner box, and here is going to the air intake manifold. So in between, you will see the MAF sensor usually. So here's the main sensor. Here's the air intake temperature sensor, because usually in the MAF sensor, there's also the air temperature sensor. Okay. This is the two wires. The heating resistor is the one that is actually heating the surroundings inside of the sensor, and this one is the temperature measurement resistor, which is the one that is actually reading the temperature that is emitted by this heating resistor. So when this resistor heats up, the other one reads it, the temperature around the both of them, to see how much the air can cool this heating resistor. But in the other example, there is just also one wire, the heating resistor. Now, the chip is inside here, and when you heat this, when the engine, I mean, when the sensor heats this, it will measure how much electricity it consumes. That's how the chip will translate it to send the signal into the ECU to identify what air fuel ratio to mix in the engine. MAF wiring. The wiring diagram of the mass airflow sensor is different according to the year, make, and model. The manufacturer designs the wiring diagram of the mass airflow sensor according to the need and demand. Three-wire mass airflow sensor wiring diagram. A three-wire MAP sensor consists of three wires: power, ground, and signal. Hot power wire reference voltage come from the ECU, ground wire, and a signal wire give signals to the ECU. The hot wire is a feed power source that is taken from the car computer. This is a reference voltage, which means the car ECU powers the MAP sensors through this wire. The ground wire is also taken from the ECU. This ground wire gives earth to the MAP sensor. A third wire is a signal wire, means the MAP sensor gives the input signal to the car ECU through this wire. 4-pin mass airflow sensor wiring diagram. A 12-volt feed positive power, MAF wire ground, MAF signal ground, and MAF signal. A 4-wire mass airflow sensor has a 12-volt positive power source, which is connected to the fuse box, fuse, and relay. The MAF signal wire goes through the car's ECU. The signal wire means the MAF sensor sends the signal output voltage to the ECU. A 4-wire mass airflow sensor has two separate grounds. One ground is for the hot feed wire. This wire is earthed somewhere in the chassis, and the second one is for the MAF signal circuit. The MAF signal circuit is given a separate ground which goes to the car ECU. The MAF sensor signal circuit is placed in the MAF sensor, which calculates how much current flows to the sensor and converts that current to the voltage and sends it to the car's ECU through the MAF signal wire. This signal circuit is given a separate ground. 5-wire mass airflow sensor wiring diagram. A MAF power, MAF ground, MAF signal, air temperature signal, and air temperature reference bolts. A MAF sensor power wire gives a positive current to the MAF sensor. Usually, this hot power wire is taken from the fuse box, fuse and relay. The ground wire gives earth to the MAF sensor and is usually taken from the ECU, or sometimes it is earth somewhere in the chassis. The MAF signal wire gives the signal to the ECU. In mass airflow, there is an air intake temperature sensor integrated into the MAF sensor, which has two additional wires, a power and a signal wire. The power wire comes from the ECU, which is usually a 5-volt reference voltage, and a signal wire goes to the ECU back, informing the ECU about the state of temperature of the ambient air. Thanks for listening.